position and the direction and the color, intensity, radius, roll-off, dozens and dozens of various parameters for every light to get just the right look. We also use special algorithms for global illumination, which simulates the interaction and reflection of objects within the scene to give it a much more realistic look. Ray tracing is a traditional technique that we use also, but it's very computationally intensive, so we also have some other techniques that we employ. Lighting and rendering together take up about 90% of our overall compute resource usage. So this is obviously a key focus for our research and development. 2 years ago, we embarked on a next generation lighting and rendering system, and it's our largest software initiative to date. But we'll talk about that in a minute. Now that you've seen a little bit of our animation pipeline, let's turn our focus to the software development process at Dreamworks. I first wanted to start out by talking about where we've invested the most in our software. Our primary authoring applications cover the rigging and the animation and the lighting, compositing, and media playback. We have pipeline tools that are the kind of the glue that connect all those other tools and groups together. These apps and tools are built on a number of large core libraries and engines that provide things like data persistence and evaluation of dependency graphs and also the effect simulations. We have geometry and pixel shaders, which are essentially a type of plugin framework for our renderer that allows people to extend and to customize the behavior of the renderer. We also have resource management tools that track and coordinate the flow of work between the groups in the pipeline and also manage our massive rendering farms. And we also keep track of various assets in the pipeline as they flow through with a digital asset management system, which is kind of like a source control system for all the stuff in the pipeline. The software development at Dreamworks happens in many corners, but there are primarily two groups. Developers are either in the technology group and they work globally for the entire studio and for all movies, or they are called production developers and they're assigned to one specific movie at a time. The technology group develops all the core components and libraries in the large-scale applications. And then the production developers on each movie come along and they create special utilities, other plugins, and wrappers that build on top of those core services and apps. And that allows each movie to customize and extend the tools to suit that movie's specific needs. Most of our core libraries and large applications are written in C++. And the pipeline tools are mostly written in Python. We also use Java for our back-end services. We develop the vast majority on and for the Red Hat Linux operating system, although we do a bit of Windows development because some third-party applications have just Windows as their platform, so we have to write plugins there. We use Intel x86-based processors on our HP desktops and HP servers. We do most of our computation with CPUs on these rendering farms, but we do a little bit of GPU development and GPU processing for specialized effect simulations. And we also use OpenGL to get really good 3D graphics performance for our desktop apps. In the earliest days of computer animation, there weren't many tools to choose from. Pacific Data Images, or PDI, became part of Dreamworks in 2000, and they were developing CG software back in the 1980s. So it's understandable then that many animation houses like PDI developed their own tools. But nowadays, there are several commercial and open source tools that run the gamut. In fact, there are many smaller production companies out there that essentially run entirely on off-the-shelf software. So why does Dreamworks continue to write so much custom software? Well, let's look at what drives the research and development. Scale. Dreamworks Animation is quite prolific. We produce between 2 and 3 movies a year, which means we have about 5 movies at any given time in production. We also create TV specials and shorts for DVD bonus material, and with that much overlap between the movies, we create more and more data to manage and process. The look of the film is very important. Our filmmakers are quite ambitious, and they're constantly looking for new ways to tell the stories in visually rich and stunning ways. And efficient iteration is key. Artists have many review and improve cycles that they have to go through to get the shots to look just right. And so our software must be very responsive, and ideally, our end goal is to have interactive performance that can really keep pace with the artists. Given these drivers, it's clear why we need to control our own software destiny in many key areas. Performance is paramount. We can always use more performance. And we can focus our attention and optimize our code on just the hardware and the OSs that we use. Whereas third-party applications often have to support a wide variety of platforms and OSs and hardware, and that allows us to keep our focus just on what we need. And we can move to a new hardware platform if and when it makes sense. And our tight relationship with HP and Intel really helps us there. Our animation and lighting systems have a dramatic influence on the look of our movies. So they're the main ingredients of what we call our secret sauce. And finally, we can customize and optimize the workflows that give our artists, special capabilities and allow them to work in a kind of a work group kind of environment with centralized asset management. Third-party applications they have to support lots of different customers with lots of different workflows, and so that can kind of dilute the focus for any specific customer. And most third-party tools are not integrated with each other, and they can't really support the hundreds of interconnected users that create films. So we have three primary goals for our next generation tools: interactive animation, lighting multiple shots in parallel, and increased rendering performance. And to achieve these ends, we're focusing on several key areas. First, cores aren't getting any faster, so we're going to have to multi-thread our software to take advantage of the latest multi-core hardware architectures. We're going to put the asset management inside of our tools, and that really simplifies the life for our artists because they're not switching back and forth between different tools. They can be right inside of the tool. And artists work better and faster when they keep their focus on the art that they're working on. So we're building powerful new OpenGL 3D viewers that allow artists to directly manipulate the objects that they're creating rather than working indirectly through property sheets or spreadsheets. And to build these new applications, we really need a solid foundation. So we're building larger and more multifunction applications with reusable components and subsystems, and then we extend and customize through a new plugin architecture from our app framework. We don't write all of our own software tools, and we want really the best of all worlds. We use Maya extensively for modeling and effects, as we've talked about, and much of our post-processing pipeline is based on third-party tools. But make versus buy isn't just about the tools that the artists use, it's also about the tools that developers use. And one of the biggest challenges that we've faced over the last few years is that our graphical user interfaces were built on an outdated, difficult to maintain proprietary application framework that we developed many, many years ago. And over time, the cost of supporting and improving that custom framework became way too great. Increasingly, we would conceive of new workflows or new UI ideas that we wanted to implement, only to realize that it would be impractical to do with our legacy framework. So we considered several different options, looked at many different alternatives, and including a complete overhaul of our existing framework. But in the end, the choice was clear. We needed to adopt Qt. So why did we choose Qt? Of course, Qt is known to be very stable and feature-rich and mature, and in addition to those compelling features, we also chose it because it had Python support via PyQt, and we've invested heavily in our Python tools, so this was key. It has a commercial license option, and for Dreamworks, when we have so much riding on third-party tools, we like to have a pay-for support model, similar to what we do with Red Hat. And there's excellent documentation and training, which has been key to ramp up the hundreds of developers that we have at our company. Leveraging the Qt framework also frees up development resources, and that allows us to focus on our key differentiators, which are the high-level user interactions and workflows, and our low-level performance of our engines and our renderer. And overall, Qt has allowed us to accelerate our pace of development. Bringing Qt in-house for new application development was fairly straightforward because we could use it pretty much right out of the box. But our biggest challenge was our massive legacy code base. And we really wanted seamless integration. We wanted to be able to use new Qt functionality with our old apps. But we didn't want to break any of our existing apps, and we didn't want to do a brute force port. So this turned out to be one of our biggest challenges, and later in the Qt in use talk at 1 p.m., Gene's going to go into a lot of the technical details of how he pulled that off. He was the major driving force behind that. So what has our experience been so far? Well, over the last 2 years, we've made great strides with Qt. Our developers have ramped up quickly, and Qt is in wide use across the Dreamworks. We're using Qt and PyQt essentially for all new UI development at the studio. And looking forward, next year we're going to be delivering our 2 major new applications built entirely on the Qt platform, our next generation animation system and our next generation lighting tool. And we still have lots of integration work and testing and tuning work to do, but we've built all the major GUI subsystems, and so far things are looking really, really good, so we're very happy. And it's clear that we could not have made this type of progress without Qt. It's really great to know that we've built our next generation tools, which are going to serve us for hopefully 10 plus years, on such a solid foundation. So, to those of you who are considering Qt for your own products or services, I encourage you to take the next step and give it a test drive, and I think you're going to be amazed, because we certainly were. So I wanted to close today with a trailer from our soon-to-be-released movie called Megamind, and I wanted to thank you for your time today and say, please enjoy the rest of the conference.
I've always believed that destiny chooses our path in life.
Is your sidekick.
And here is your pig.
You are destined for...
Destined for what? I didn't quite hear that last part.
They came to our world together. But they were destined.
Our baby can fly.
Yes, nothing but the best for you, darling.
To take different paths. Can we keep it? One would be here.
Happy Metro Man Day, Metro City.
I love you, Metro Man! And I love you, random citizen.
While the other
Table for 2.
was feared.
What? What?
But on November 5th,
A new threat has come to Metro City.
Consider yourselves under new management.
And Metro Man is nowhere to be found.
He'll destroy the whole city.
I'm sorry, I'm finally free to get in touch with my true power. Making awesome music.
You're kidding, right?
the world needs a hero.
You need to be that guy.
Now, this is a strange turn of events.
He will answer the call.
Hello?
It's hello.
Hello? Like that?
And the superhero movie.
Just a few alterations, and I will be done with your cake. I'm calling it the Black Mamba.
Will never be the same.
Let the showdown begin!
Will Ferrell,
Where did you park the invisible car?
Tina Fey,
What's the plan?
It will sleep not dying.
That's a good plan. I like that plan.
Jonah Hill,
Quick, the spread.
All out.
Well, use the forget-me stick.
Oh, right.
I think it's working.
and Brad Pitt.
Check this out. I have eyes that can see right through lead. Huh?
Dreamworks, Megamind in 3D.
Do you have your disguise?
What? Wow, you look fantastic.